Hi, welcome to the pre-calculus lecture series. And we are starting a new chapter today. We're going to start chapter section 3.1. So chapter 3 is the chapter we're going to talk about the two kinds of new functions. One is the polynomial functions and the rational functions. And in the section 3.1, we're going to talk about one of the most popular polynomial functions. And we call it the quadratic functions and the models. You know, in the real life, a lot of real life situation can be modeled by the quadratic functions here. So we're going to, in the section 3.1, we're going to take a good look what is the quadratic functions and what are the good properties, characteristics about the quadratic functions here. Okay, so let's go to our lecture notes here. Okay, so let's take a detailed look. What is the quadratic functions? Okay, let me go to our lecture notes here. Okay, so the quadratic functions. Okay, so like we said, in this chapter, we are talk about is the polynomials, right? And so the quadratic is a very special polynomial functions here. So we said a quadratic here. So a quadratic function is a polynomial. It's a polynomial functions of a degree of 2. Okay, so a quadratic function is a function of the form okay, so we said f of x is equal to ax squared plus bx plus c here, and here a cannot be equal to 0, because if a equal to 0, then the x squared term going to cancel, right? So we said a quadratic function is a polynomial with degrees of 2. So maybe you don't understand what is the degrees of 2 right now, because in the later chapter, in the later sections, when we talk about the polynomial, we're going to formally define the degrees. So, but basically, polynomial will tell you you have to have x squared terms, okay? And so for these square terms here, you can, you have to have x squared, but so like for examples here, if you have a function, is f of x equal to 3x squared minus plus 3, right? So this is okay. This is a quadratic function. So as long as you have this square term, I don't have to have the remaining terms here. All right. So also like if I say f of x is equal to 4x squared minus 4x, this is a quadratic also because I do have this square term. But if you say f of x equal to the 3x minus 5, then this one's here, this is not quadratic because this does not have an x squared term. So this in turns, in fact, is what? Is a linear functions, right? So make sure the quadratic you know is have the square term. Okay, so then the next things here we're going to talk about is the standard form of the quadratic functions here. So the standard form of the quadratic functions, also these standard forms here, okay, so the standard form here, we also have different terms, we call this a vertex form, okay. So we call this the vertex forms here. So we say a quadratic function so the quadratic function f of x is equal to ax squared plus bx plus c, and can be expressed as the standard form. Okay, also the standard form, don't forget, we also call the vertex forms, right? So it's f of x equal to a to the x minus h squared plus k. Okay, so then the graph is, so the vertex, the reason why we call it vertex, because the vertex is at h and the k here, okay? And so like if the, so like your, okay, so your quadratic is going to look something like this. If this one is not, I don't want to touch the, okay, so here, okay, so if you have if this is your function, right? And then this one's here. So if your quadratic open upward, that means the a has to be greater than 0, all right? And in here, this is your vertex, is h and the k here. Then the same way, so like if you have quadratic here, if you have like open down, right? So if your quadratic open down here, that means your constant a has to be less than 0. And here, the top here, this will be your vertex h and the k here. Okay, so be very careful a few things here. So when we change to the vertex forms here, right? So here, you know, in order to be a h here, here has to be minus, is x minus h, right? So that's, it's kind of like we talked before, like a transformation. That means x equal to h. And here has to be plus k in order to have a case here. And the way we change to the standard form, we are using what? We're using completed square methods here, right? So if you kind of forget what is a completed square method, you might want to, you know, go back to your algebra book and do a little bit of review about what is the, you know, completed square. We will do several examples to show you also, but you need to know what is that, all right? So in here, I think we might need more space here. So I give it some space on the next pages here. Okay, so now in here, the first problems here, they said, okay, for the f of x equal to 2x squared minus 12x plus 13, I want to change to the standard form. That means I need to change to the what? I need to change to the vertex form here. So, okay, so this is how we start, right? We say we need to use the complete square. So this is 2x squared minus 12x plus 13. So in order to complete the square, I need to work on these two terms first, all right? Okay, so let's see here. How do I work on these two terms? You factor the 2 out, right? So this will, you have x squared minus 6x, right? And plus 13. Okay, so remember the completed square. So which formula we use to do that? We say, you know, so this is how we do we use this formula, right? We say a plus b square or minus b square is equal to the a square plus or minus 2ab plus b square, right? So we want to match this form. So if here this is minus, it's become a minus b. If it's plus, it's a plus b, right? Okay, so now let's see here. So here we say this is x squared minus 2ab, right? So we say it's 2. I need to divide 6 by 2, so it's 2 times 3 times x here, right? So I break this. And now you have this 3 here. In order to do that, right, you need to have a b square. So what I need to add here? So I need to add 3 to the square. Did you see that? All right, so because it's x squared minus 2ab plus b squared. Okay, so here I still have this 13 here. But think about it here, right? So from here to here, right? Take a look at these terms here. So 2 times 3 to the square, 9 is 18, right? you cannot just add any number there. You add 18, what do you need to do here? You need to minus that out in order to balance it, right? So you need to, you need to minus that out in order to, so here is the most important part. If you do the complete square correctly, that would do it, or, this is the place probably a lot of you will make the mistake. Okay, so now I will say here, this will be 2. So this will be a minus b squared. So it's x minus 3 squared, and minus 13 plus 18. Negative 18 is what? It's a 5, right? So now I know this is my standard form, and also based on what we just talked about, the vertexes here. So let's write it down. So what is the vertex here? Because the x has to be minus something. So this is 3. So what is the case here is negative 5, right? So the vertex is -3 and the negative 5 here. Okay, so now the next thing here, the part B is I need to find the X-intercept and the Y-intercept. Okay, so the Y-intercept is easy. So how, you guys remember how to find the Y-intercept here? Y-intercept is you let the x equal to 0, right? So if you let the x equal to 0, f of x 0, so if you say the f of 0, that means 0 minus 0 plus what is 13, right? So the y-intercept is at the 13th here. Now the x-intercept, that means you let the y equal to 0 here, right? So when you let the y equal to 0, and that means I need to put like the 0 is equal to, so in here, so I need to say this is 0 is, okay, so that means, okay, so that means 2x squared and minus 12x plus 13 is equal to 0. And sometimes you can factor, right? So after you factor, then you set each term equal to 0. That's your x-intercept. Unfortunately, this one we cannot factor. So I need to use the quadratic formula. Okay, so the quadratic formula will tell me x equal to 2a. So if you remember, the quadratic formula is 2a negative b plus or minus b squared minus 4ac, right? So that's our quadratic formula. So 2a, so it's 2 times 2 is 4, right? Negative b is 12 plus on the minus, right, b squared, so it's negative 12 to the square minus 4ac minus 4 times 2 times 13. Okay, so if you calculate this one, so you will get this one is be a 6 plus or minus square root of the 10 to simplify it. So that means x is going to be very close to, you just put it into the calculator, will be close to 4.58 and 1.42. Okay, so now after this, we'll be able to, right? So let's say find the graph, right? Find the graph of f. So first, let's see here. Okay, so let's find the graph here. So first, let's find the vertex. So it's 3 and a negative 5. 1, 2, 3. 1, 2, 3, 4, 5. So here, right? So this is my vertex. And because my A here is a positive, so I know my graph going to what? My graph is going to open upward, right? Okay, so now the next things we can use is very useful is y-intercept. Y-intercept we just did is what? Is 13, right? Okay, so 13. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whoa, it's here somewhere, right? Okay, now the X-intercept, we just calculate, going to be pretty close to the 4.58. So this is 3, 4. So it's somewhere here. Then another intercept is 1.42. So it's somewhere here, right? So by using the X-intercept, Y-intercept vertex, we'll be able to graph. So this is our, let me see, I can graph this or not. It's very difficult to graph on this writing pad, but you can see here. So that is what my parabola looks like, right? So the last things here, they say what is the domain and the range, because it's x continue goings, right? So the domain is what? Domain is all real numbers, right? All real numbers. Yeah. Then what is the ranges here? The range is the smallest value of the y's here, right? It's -5. Everything else is going to infinity. So the range here is from -5 to what? Positive infinities here. All right. So that is how do we find the, how do we find the quadratic function into vertex functions here. Okay, so the next thing here, you said the maximum value and the minimum value for quadratic function. Okay, so just by, so, just by the graphs, right? So in here we say, if, so in here, that we have here, so we know the f of x is equal to ax squared plus bx plus c. We also know we can change this to the x minus h squared plus k, right? Okay, so in here we say that for a greater than 0, so for a greater than 0, so I know my function is open up, right? So this is my open up. So if I open up, so do I have maximum value? No, I don't, because the value continue go to the infinity. But I do have what values here? I do have the minimum value, right? So what is the minimum value here? Hey, here is my minimum value at this point, right? So this point is my minimum value here. And so what is this point? This point is vertex, right? So the vertex here is h and k. So here, this is my vertex. So what is my minimum value? So the minimum value for these ones will be what? So the minimum value will be equal to what? Will be equal to k, right? Will be equal to the y values here, correct? So like the same way we said, if I have a is less than 0, if a is less than 0, I know my quadratic is going to open like this way here, right? So if this way, so what is this value here? Hey, this is the tallest point, right? So if this is the tallest point, so what type of the value I have here? I have a maximum value. All right, so also you say, hey, what is this point here? This is the HK, right? This is my vertex. So my maximum value is here, right? So my maximum value here is equal to K, the Y value, whatever the Y value, I calculated that. So that's why I said as soon as you can find, right, the vertex form, then you can see where is the maxima and where is the minima values, right? Okay, so let's take a look here. So this is the second example. So let's see we'll be able to do. So let's say that, hey, for this problem here, right, for this quadratic, first let's change it to the standard form. Okay, so just like we did before, we need to use what methods here? Complete squares, right? Okay, let's try one more time to see we know how to complete the square. Okay, so let me give a little bit more space here. So we said f of x here is equal to the 5x squared minus 30x plus 49. So for the complete square, which two terms we need to work on? These two terms, right? The one with the x here. All right, so now I take the 5 out, factor it out. This is x squared minus what x? 6x plus 49. Then remember we use a minus b squared, a plus b squared. So what I need to do is here, I need to break the 6 to what? 2 times 3 times x. So now I break it, right? So here, that's the 3. So in order to complete the square, what I need to do here, I need to plus the 3 to the square. Am I right? Okay, so I have a 49. 49 was always from here. Then in here, what did you do here? You add some numbers here. So 3 to the square is 9. 5 times 9 is 45. So you add 45. I know I cannot just randomly add some number. So if you add 45, what you need to do here? You need to minus 45 out, right? So like I said, this is the most important part. If you remember, do that, and then you probably will get the complete square correctly. Okay, so this is the 5. So inside here is x minus 2ab plus b squared. So it will be x minus b to the square plus what? Plus 4, right? Okay, so I know my vertex here. Okay, so my vertex will be 3 and what? 3 and 4. Okay, because this is open up, so I'm going to have a minima. So hey, what is my minima values here? The minima value is a case, right? So minima value is here is what? Is 4 because I opening up here, right? So you can basically, if you want, you can just sketch the graph, and then you can, you set it here. So in here, you can say it's 3 and 4, right? So basically, you can put the vertex here is 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So this is 4. And then they opened up, right? So they opened up, and I don't have enough space here because the name Y-intercept, so they open up like this. So they don't have the X-intercept. Right? So that's why the minimum value here is 4, correct? Because it is the opening up here, okay? All right, so now let's take a look at example number 3 here. We did a lot, so I hope that right now you are really good at complete the square. Okay, so now let's take a look here. You said, okay, so let's do it one more time. So this is f of x equal to the negative x squared plus x plus 2. I need to change to the standard form. Okay, so one more time. Which two terms we work on here? These two terms, right? Okay, so these two terms we work on. So factor any constant in front of x squared. So this is x squared. So what here? Minus x, right? Plus 2. Okay, do the same way. So this is negative x squared. Oh boy, so here is negative x. So what I can do, you always need to take the 2 out, right? So this is 2. But here only 1. What I need to do here? I need to times 1/2, right? To get here is 1. Then to the x. Now I know, oh, this is my base here, right? So now here, what do you need to do here? You need to add what? 1/2 to the square, okay? Then you add 2. Right now, you need to adjust the constants. Remember what I say, if you remember. So this is the 1/2 to the square is 1/4. Then you have a negative. So you minus negative 1/4. I cannot just randomly minus negative 1/4. So what I need to do here, you need to add back 1/4, right? Because here you minus 1/4. So you need to add back 1/4 here. Okay, so now finally, so this is negative x what? Minus 1/2 to the what? To the square, and 2 plus 1/4, what is that going to give you? is plus the 9/4, right? Okay, so now my vertex here is going to be 1/2, and this is 9/4. And because here the A is negative, so what happened here? My graph going to what? Opens what? Downward. If I open downward, I'm going to have what value? I'm going to have a maxima value through here, right? So what is the maxima value? Hey, I already calculated the case. So maxima value is 9/4 here. Okay, so now let's try. So this one's here, let's try to graph it. So here, okay, so yeah, this one is easy to graph. So the vertex is 1/2, and the 9/4 is a little bit more than 2, so it's somewhere here. Okay, then the y-intercept is 2, so it's here. All right, and then the x-intercept, this one we can calculate the x-intercept. X-intercept is y equal to 0. That means negative x plus 2 equal to 0. That means I can x squared minus x minus 2 equal to 0. Then I can do this is x minus 2, x plus 1 equal to 0. I got it. So x equal to 2, x equal to negative 1. Okay, so now x-intercept is 2, so it's going down here, negative 1 is here, so you connect here. So this is what your quadratic going to look like, right? So because it's open downward, I have, I have the maximas here. So the next thing here basically is telling you here is, of course you can find the, you use the vertex form, right? So your first one, you can change it to the vertex form, and then you can use the vertex form and try to find the maximum or minimum values here. But then the next ones they tell you here, okay, if you don't want to change to the vertex form, you don't want to graph it, you can just use algebra to solve it, okay? So here it will tell you here the maxima. Okay, so that's why here how do you use the algebra to solve it, right? So we say the maxima. So it's maxima. Okay, so the max over minimum value of f of x is equal to the ax squared plus bx plus c here. So the maxima or minima occurs at x equal to the what? Negative b over 2a. So basically, it's telling you, right? So this one is equal to the h value in the vertex form. Okay, so if you change it to the vertex form, that's what is x, but you don't have to. You can just use it and to change that, right? So you can just plug this number. So I know if a is less than 0, right? If it's less than 0, I'm open downward. So now I know what number I have, maximum and minimum. The maximum number is equal to, you just plug in the negative b over 2a, right? So this is what, this is equal to what we did example. This is equal to the k values, right? So in the vertex forms, right? Okay. All right, so now in here, the next one's here. So if we say a greater than 0, if a greater than 0, I know my quadratic is open upward. So if you open upward, what do you have? You have a minimum value. So the minimum value is the same thing. You just plug in whatever the number the x's here, right? So here is very important, right? So that is the x, you know, where is the maxima or minima? That's the vertex. That's the x coordinates of the vertex here. Okay, so let's take a look here, right? So in here, the problem is here. They say, hey, find the maxima and the minima value for each quadratic. And I don't need to change it to the vertex form anymore. Okay, let's see what do we do here. So this is f of x equal to the x squared plus 4x. So compared to our standard form, you know, our standard form is f of x equal to the ax squared plus bx plus c. So let's try to write it out. What is my ABC? So a is the constant in front of x squared. So a is 1, correct? Okay. Then b is the constant in front of x here. See here, right? So b is 4. C is the constant. So do we have any constants here? No. So C is equal to what? C is equal to 0. So I know these numbers here, the vertex x here going to be negative b over 2a, right? That's our formula. So it's negative 4. 2 times 1 is 2. So it's negative 2. So I know at negative 2. So this function, because a is positive, so I'm opening what? Upward. So at x equal to negative 2, do we have a minima or maxima? We have minima, right? So what is the minima value? You just plug in the negative 2 to your function. So this will be the negative 2 to the square plus 4 times the negative 2. And so what is here? You will get a negative 4. So that means, you know, this value here, right, the vertex is negative 2 and negative 4. So going to have a minima value at negative 4, right? So this is the way you don't have to change it to the vertex form anymore. Okay, let's take a look at the part B here. The part B, the gx is negative 2x squared plus 4x minus 5, right? Okay, so now in order to do that, let's write it out, the formula a equal to negative 2, b equal to 4, and what is c here? Hey, don't forget the negative, right? So it's a negative 5. Okay, so now I know the x here is equal to the negative b over 2a. Let's try one more time. Negative b is negative 4. 2a is 2 times negative 2, so it's negative 4. It's a positive 1, right? Okay, so because here, look here, the a is negative 2. What is the number here? This is a negative number. So because the a is equal to the negative 2 is negative, so what my graph going to do? My graph going to open downward. If I open downward, then at x equal to 1, I have a maxima or minima. I have a what? I have a maxima values, right? So what is this maxima value? I plug in that 1 into my function. So this will be negative 2, 1 squared plus 4 times 1 minus 5. And what I have here? I have negative 3 here. Okay. Okay, I have a negative 3. So this will be my what? This will be my maxima numbers here. So this is 1 and negative 3, right? So everything else is smaller than the negative 3. Okay, let's see it. All right, so this is the basic introduction about the quadratic. So the key things to remember in this section is how to change to the vertex form, right? So the vertex is also the same place. You have your local, you have your maxima and the minima, right? And how do you decide the maxima and the minima? It's depend on your curve. Your parabola is open upward or your parabola open downwards. So how do they decide it's open upward or downward? It's based on what? It's based on the constants, right? The a constants in front of the x squared, right? Okay, that's it. And that is the section about the quadratic function. And hope that you will have good understanding about the quadratic function. And then the next section we're going to talk about the general polynomials. All right. Okay, have a good day and looking forward to talk to you in the next videos here. Okay, bye-bye.